Good evening. Today we're going to be looking at a, what's that, Andis brand facial or any kind of hair trimmer. The model number is BTF3. This is a cordless rechargeable trimmer. I guess it's fairly basic. One on off switch, not much more you can expect from a trimmer. And the complaint is that it does not charge, but it will run when plugged in, so we will verify that. Just a thought before I go any further. Input, there we go, 4.9 volts, 500 milliamps is all it requires. So here's our charger, throw it away. Is it rated to what it should be? Looks like a cheap universal charger, and it's 4.9 volts, 500 milliamps. Just a random thought I had, may not have been the right charger for the unit. It was not purchased new, so it's Andis branded as well. Here's a good start. This has quite the long cable. Let's check it has the expected output. I didn't actually check, I'm assuming it's positive center. 5 volts, that'll make up for any drop across the length of cable. It's got to be a good meter. It's about 2 meters long. Now if we plug it in, no light. There was a suggestion that there may be a light if you wiggle the end of it. Certainly not that apparent at the moment. And does it turn on? So that's interesting. It's getting power through the socket and it'll run off it, but it won't charge. Now, 4 screws. For those of you who liked the Microscope, I have purchased a camera. It is in transit, and just as soon as that arrives, I may do a review video of the camera. But, yeah, I may as well do. There's not too much out there about cameras either. The one that I've purchased, I mean, the difference between the one I purchased and the next one is about $300, $200 to $300. So I think for the price, it's probably going to be fine, but there's been suggestion that they may not go the distance, but I've seen other people using the same camera, so we'll see how it goes. Who knows, maybe I'll have to do a video fixing a camera. Anyway, screws are out. Looks like the top cover's just going to lift off. Here we go. Great big clunky on-off switch. Nothing wrong with that. A motor on a offset, with an offset cam, it looks like. Is it an offset cam? Actually, I don't know quite how that is. Yeah, it might be. I won't turn it on while it's exposed. There, looks like it does retain slightly in the top case. And what have we got on the side there? The charge circuit. One cell, kind of looks like, no, it's not big enough to be an 18650, I don't think. Let's extract that. How easily is it going to come out of there? Probably want to lift the charge port out. We'll take the charge port out. Just keep an eye on where those cables are located. We've got the LED, which tucks in posts in there. And that's all going to come out. We should be able to tuck that back in the way it came. And yeah, I've got, it could just be flux, a horrible white smudge just there. That's possibly just flux. Yeah, I don't think it's had water in it. Oh, but we do have an explosion. I will do my best to show you because it is rather small, but it appears to be probably a linear regulator. A little 5-pin SOT23, I think they call it. But I'll see if I can get you a shot through the microscope with the camera that I've got. Yep, this is a lithium-ion battery. It's 3.7 volt, 750 milliamp hour rated. But a single cell at 3.7 volts has to be lithium-ion. A single NiCad cell is only about 1.2 volts. So much for it being a new device. Look at the date code, 2014. How long do these cells sit around for? We're now in, like, mid 2018. This is 4 years old, just over 4 years old. Is the device that old? I don't know. Be interesting to know if they're still on the shelf. It doesn't have a date on the back of the device. That's pretty interesting. Unfortunately, I can't do any better than through the eyepiece at this moment. But there you can see the charred remains of what I'm guessing is a linear regulator for obviously charging the battery. It may also be a switch. No, the battery's flat. Nah, okay. But we'll have a closer look at the circuit around it. Give you an idea of where it sits. Maybe I can read a number off that, and hopefully we can find a replacement. So there's another shot of the board, and there's our little device smoked up. We have there's a 6-pin device there. This is a 2 FETs in one package. We've got the drains are all paralleled up along pins 6 to 8, and we've got 1 is the source 1, I think, or source 2. 2 is the corresponding gate, 3 is another source, 4 is a corresponding gate. The gates are being driven by this little package here, and I'm not too sure yet if that's for charging or for driving the motor. So yeah, don't know yet. There's a lot going on in the on-off switch. There's two rows of pins, 3 pins. When it's in the off position, the 4 right-hand pins are connected together, and when it's in the on position, the 4 left-hand pins are connected together. It's just sliding a contact across between the two. And then we've got 2 large diodes, 1 smaller diode, and not much else. So let's see if we can get a number off that part. So let's have a look. The number on the part is KK80, which I can't find in a semi brief search on Google. Most stuff pops up almost right away. Add the keywords SOT235 and lithium charger, and you don't find anything exact. So let's go through how I might try and find such a little part. You can download the SMD components, this information PDF. I found it on Google. I can't remember where. Look for smd-codes.pdf. It'll probably pop up. It's dated 2007, so that may not help us if this is actually after 2014 or whatnot. Depends how long this part's been around for. But it's got just over 1,000 pages of SMD codes, markings on SMD devices to help try and figure out what they are. So if we do a find for KK80 and see what happens, and no matches were found. That's unfortunate. Now I did have another file which SMD ID catalog, another one there that I found. Let's see what's in here. So if we search KK80, nope, okay, so that's obviously not going to help us. So now let's go to RS components, and one way we can do it is to sort of scroll through their list of parts and see if we can find something similar that might match the pinout, for example. So under all products, let's have a look. What have they got? Power supplies and transformers, no. Semiconductors, oh, scroll. What have we got? Power management chips, probably under power management ICs. Down the left, oh, battery charge controller ICs, and we have 508 products to choose from. So if we go package type, you can filter down the left side here, choose various specs and things about it, and filter it down. So if we go package type and we want SOT 23, so we'll tick SOT 23 and apply that, and that gives us 26 products. That's not much to choose from, so there's probably no point really filtering it any more than that. I suppose we could go pin count, because we've only got 5, so that'll knock off a few. That gives us 18 products to choose from. What else is there? Dimensions are all going to be very similar. Input and output voltage, probably all going to be similar. So let's see what we've got. The first one is a microchip MCP-73831T, and there's my scroll bar. Lithium ion, lithium polymer, 3.7 to 6 volts supply voltage, which is okay because we're putting 4.6 in, so that's okay. I'm sure the sizes will be the same because it's a standard. SOT 23 defines a standard, I believe, and not much else to go with it. But the next one down, you'll see it's capable of 500 milliamps charge current with a 4.2 volt maximum output, which is about right for lithium ion. And what else do we have there? The input voltage 3.7 to 6, so that's good. So this is looking like a possible candidate. Let's click on him. I can't imagine it's going to be any more than 500 milliamp. Well, considering that what did they say on the 500 milliamps was all it said on the back of the shaver. So yep, that'll do. But what is the pinout? See that we can purchase it for 86 cents or 99 cents including GST each, and you must buy 5 minimum, so I can live with that. Let's have a look at the data sheet. So data sheet, linear charge management controller, blah 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 blah. What do the pins look like? So we've got these pins here. Pin 1 is stat, which I'm going to say probably means status, and pin 2 is our ground, pin 3 is battery, and pin 4 is input. And if we scroll down, we will see that we have a list of pins that will prove me right. Okay, here we go. Pin 1, stat, charge status output, probably goes to the LED. Pin 2, battery management 0 volt reference or ground. Pin 3, battery charge control output to battery. 4, input. 5, current regulation set and charge control enable. Okay, which is precondition. Fast charge and termination currents are scaled by placing a resistor from program to ground. The charge management controller can be disabled by allowing program to float. So that's cool. How does this all relate to our little board? Let's have a look. So what have we got? Pin 1, there's something I can point with. Pin 1 up the top left here. It appears to go pin 1 runs up here, along here, and up to this resistor, and into this wire, which is labelled LED minus. So there we go, pin 1 for status. That obviously turns the LED on to show it's charging, and it probably goes high or when it's not charging, so the LED will turn off. That's good to know. Pin 2 is labelled as ground. So where does pin 2 go? Pin 2 goes to this series of vias here, and they go through to what appears to be pin 2. These vias go through to the other side, which come along and come out these 3 here. That travels up and around to that black wire, which is in minus, and being in minus, that's our, so it's not necessarily battery negative, but it is negative with reference to our input voltage, so that's our charger input ground. It looks like the battery ground may be slightly different, but I haven't followed that through yet to be sure. Pin 3, VBAT, and yeah, we can see that pin 3 here at the bottom left corner comes along to battery positive, so that's good. And what about pin 4? That's supposed to be our charge positive input, so that comes along, that comes along to these vias here, and through to the other side, and appears to go into our switch. It goes to LED positive, because of course the LED needs power only when the charge is plugged in. Okay, yep. Wasn't 100% about how the switch worked before, but yeah, pin 4, we have it the way around we had before. Pin 4, bottom right, goes from those vias across to the switch here. The right hand connection is joined to the third one, second one along from the right, which goes off and to our DC in jack. So that's power in, and then of course just our programming pin, which is 5. So we need to have a look at the resistor value on that and decide if it's the same as what this new one will require. That resistor is 2551, which should be 255 and a 0, so 2.5k ohms. Is actually measuring somewhere like 390k in circuit. Wondering that could be damaged. It's just connected to ground, although thinking about it, it would take a lot to damage that. I mean, current through 2.5k at 5 volts is not a lot, but I might just check it out of circuit. But yeah, so that's tied to ground, and our data sheet said what? Preconditioning is used to trickle charge a cell when it's below a certain voltage, which is dependent on the value of the resistor. By the sound of it, once the voltage reaches a certain level after the preset chosen, then it will go into fast charge mode. So yeah. Now, section 1, electrical characteristics for preconditioned current options. What does it say? There we go. Fast charge current regulation is scaled by placing a resistor from the program pin to the ground. Program resistor and charge current are calculated using this equation. The preconditioning trickle charge current a ratio metric to the fast charge based on the selected options. So okay, so this resistor really sets the maximum charge current, and then the preconditioning is automatic and will happen anyway based on what you choose. So if my math is correct, R prog would equal 1000 volts over 500 milliamps, which is going to be 2K. So that resistor being set at 2.5K, no, what's it doing? Calculator no work. 400 milliamps, which, yeah, makes sense because our power supply is only 500 milliamps. So, you know, let's not overrate everything. Sorry, underrate everything. Yeah, cool. Okay, so 2.5K. I'm going to pull that resistor out of circuit and check it at some point, but I think that based on that information, we have managed to find a suitable donor. And MCP 738312, which I will have to go and purchase. Pretty sure I don't have any of those. I've got some small devices, but not charge controllers, so I'll double check. I don't think I've got any junk that I could even take one out of. But oh, if he wants it, he's going to have to wait a week. What have we got? 5 working days. Oh, no, they've got some in stock for next working day delivery. Excellent, I might have this week. Alright, the part's been ordered and arrived today. This is a couple of days later. So, let's solder it on. I got, what have we got? 1, 2, 3, yeah, 5 of them. Minimum order quantity. So, cross fingers that this will actually do the job. Alright, a bit of flux. A bit of hot air. And a bit of tweezers, because my fingers are not going to cut it. And hopefully it's not bonded to the pad too much. It's very, very black in one corner. So hopefully it comes off cleanly. It feels, oh, there it goes. I think it just may have, oh, I think it's left part of the device behind. Huh. We'll have to clean that up with a solder iron. Yeah, very much charcoaled that pad. Let's see if a little bit of a solder might bring it back to life. So there's a rough close-up. In the bottom right you can see that the pad's turned to charcoal, and some of the trace to it has come away, so we'll need to scrape away that carbon, make sure it's not conductive through to the pad to the left before we put the other part on. Yeah, we'll just solder it on, it's a bit easier. Less stress on the chip, not having to get it really hot as well. So we'll pop a little bit of flux. I just wicked the pads nice and clean so that we have a nice flat surface for the package to sit on. That looks roughly near enough. Not too bad for the naked eye. Don't need a microscope for everything, it just makes life real easy. Just tin up the tip and go one leg at a time, I guess. That looks good. Yeah, it looks fine. And verified under the microscope to prove it. Now, one thing that I kind of overlooked, which is a bit silly of me, but keep in mind that when you're working on something with the battery still attached, sticking wick across the pads may not be a good idea, because there's battery voltage definitely on there. Well, I think it's on there. One of the leads does go direct to battery, so we'll have a look at that. But the battery's pretty flat, so we should be fine. But it's a pretty basic circuit. Now for the moment of truth. Will the green light come on? Did all our datasheet research prove correct? Or have I ordered the wrong part? Aha! We have green light. Look at that. Let's see if that's getting hot or anything stupid. I'd imagine it would get warm, but it's only running 400 milliamps. Yeah, there's a little bit of warmth there. There's quite a lot of warmth there. It's actually getting really hot. That can't be right. Maybe this thing runs right on the limit. What sort of voltage is on that battery? It'll give us an idea maybe of what sort of current it's forcing through. 3.8 volts. So that could be pushing full current actually at the moment. I guess the battery's pretty depleted, so if we let it run for a full charge and if it survives, it's probably going to be fine. Datasheet says maximum operating temperature is 85 degrees, so that's been sitting there for a while, and it is pretty warm, but it's not 85. I really don't think that's 85. Then again, you know, how good's my finger? It's probably closer to around 60. What's that battery voltage at? .9. Oh, 3.89. So it's slowly coming up. I will let that sit and come back once the light goes out, I guess. We'll just see how long it takes and make sure it's all happy. Okay, so we're half an hour into the charge, and it's really dropped off. It's quite cold to touch, so that's a good sign. Either that or it just burned out inside and stopped working. What are they? I doubt it. I really don't think so. So let's have a look at the voltage across the battery and just get an idea of where it's at for charge. And we're at 4.17. Now 4.2 is the maximum, so we're pretty close to charged, and makes sense. Getting colder, it's going to draw less current. And for want of a bit of proof, just so it hasn't blown up and I'm telling a bunch of porkies, 4.174, there we go. And the light's gone out, and that's roughly 40 minutes, roughly 40 minutes charge time, which for a small cell like that is probably on the money. It's our final charge voltage there. No, you can't really see that, can you? It's kind of pointless. 4.15 with it unplugged. Now we just need to attach the motor and see how it goes, see how long it goes for. Okay, let's see if it still runs. And I promise, this is the first time I'm turning it on. I'm not cheating. So I had to put it back together, put the screws in it again to support the motor. The mechanism was not, I didn't trust that it was supported properly at that end, and I don't want it flying apart. So here we go, we'll turn it on. Well, it sounds good, sounds sort of like a pitch I'd expect from a full speed motor off a full charge. I'm not going to shave my arms as a test. And now that it's used a little bit, we can plug the charger back in to see what goes on. Green light. So I did have a look through just in case there are some more high powered devices, and there was a 2.6 amp, believe it or not, in a SOT23 package. That would need some heavy thermal dissipation, I would imagine, but yeah, 2.6 amp capable. The only difference is the pinout was different. So yeah, I think we're on the money with it being a half amp. Most of the other ones on the listings were half amp as well. Awesome. Okay, well, another fix, and hopefully that helps you to figure out how to find a part for your particular circuit when you can't identify it exactly. When you look at the circuit and you know what it is, you see where it's connected. In this case, that was connected to our battery, so it's quite likely that we decided it was the charge control IC. And then given that it was completely burnt, it kind of led to, you know, possibly they plugged in the wrong charger. I'd almost guarantee that's what happened. I don't think it's failed through to thermal overload. While it does run warm when it's charging, it's not stinking hot, so I don't think it burned itself out. So yeah, thanks for watching, and take care till next time.